Yes, thank you. So indeed, we will be presenting the Open Research Knowledge Graph, or ORKG, and then specifically a new service we recently released called ORKG-Ask. So if we have a look at the outline of today's presentation, I will start by quickly explaining what is the ORKG. So some of you might already know what is the ORKG. If not, yeah, there is a short introduction. Then I will move on to discussing the front end of ORKG Ask. So as was just said, I mostly work on the HCI parts, so the front end development parts. And then Yaser will take over with the ORKG Ask backend, explain how that works. And then finally, in the last 15 minutes, you have a chance to try it yourself. So there will be some instructions on the screen, and you can just try out the system yourself, collect some data, and play around with it, and possibly let us know what you think. First, a bit to start about the ORKG. So the ORKG is trying to solve issues with scholarly communication. So as researchers, you are all aware that if you write an article, you mostly do this in a narrative document-based form. So this narrative way is really suitable for humans. So humans can read this, can consume the content, but it's not that great for machines. So in that sense, machine actionability is lacking of this way of representing the knowledge. Machines have to parse the content. We need NLP tools and so on to understand what is being written in the paper. Here we have an example. So we can see there is a set of scholarly documents, and this set is really big, as we all know. It's billions of papers. And if you then look for specific articles, for example, using Google Scholar, we can see if we have a very specific information need. So we want to know, or we want to find articles that address author name disambiguation using graph embeddings. We get back more than 18,000 results. And there's not that many papers that specifically discuss this topic. But because of this document-based form in which the knowledge is stored, and because of the keyword-based information retrieval, this is the number of articles we get back. And the ORKG is trying to do something about this. So here on the left, we can see an ORKG representation of articles. So the articles are represented as structured knowledge in a knowledge graph. So we just had a nice introduction about knowledge graphs, so I can skip that. That's really great. But here we can see a very simple example of such a graph. We have the metadata at the bottom, and here we have something called contribution data. So that is the data that's really presented in the article, and that's the reason why the article was published in the first place. So this could include numbers, numeric data, findings, conclusions, and so on. And we are trying to capture that knowledge and put it in a knowledge graph. That is the ORKG. That's not what I'm going to discuss today. So today I will be discussing ORKG-Ask. And that uses still the unstructured way in which knowledge is presented. So here we have the documents, and the documents are used as such. And we then also have an input as a research question. So we can ask questions from the corpus of documents. The benefit here is we don't rely on the structured data, which is not, of course, available in large quantities. And we can just use the articles that are already out there. So ORKG-Ask is relying on a corpus of approximately 70 million articles. This is thrown into an LLM, and we get the questions being answered per paper. So this also resembles a RAG approach. We also just heard that, so that's great as well. But I think Yaser will also explain a bit more in the backend part about this. And in the end, our goal is then to also use the content generated by ORKG-Ask and feeding that back to the ORKG. So building the knowledge graph from LLM extractions. This is something we currently do only on a very basic level, as I will display later or show later. But in the future, we plan to really focus more on this aspect. So in the end, ORKG-Ask helps researchers to find and explore research articles, basically what scholarly search systems do. So that's the goal of ORKG-Ask. If we look at the architecture, we can see there is a user interface on top, and we have three main components. So we have a vector database in which the articles are stored. Then we have large language models And then we have knowledge graphs that further help to fine grain and filter results. So the first two parts are really part of the RAG approach, and the knowledge graph there enhances the search further. And of course, everything then, the data comes from the paper corpus we use. So now I will focus on the front end. I will explain some of the features we have before moving on to the details about the LLMs and so on. So this is the search result page in Ask. So here on the left top, we can see there is a search query, which is indeed a natural language question. And then here we have a sort of hybrid table list results where we can see that questions are being answered. So one thing we really try to do with Ask is trying to create a production service. So go beyond a research prototype. So we really try to focus on usability as well, and try to provide features that are helpful for researchers. So a lot of the efforts that we do also goes into making it usable, making it stable, making it maintainable, and so on. So these are some of the features. I won't discuss all of them, but I will just go over a few of them quickly before you can also try it out yourself. So the main part is having answers to questions that are being asked. So as I just showed, there is an input where you can enter your search query, and then there's two ways of answering this question. There is an answer per paper basis, meaning that each of the listed results will get an answer to this question, but also there's a synthesized answer, meaning a combined answer of those different articles. I'm not sure if there's too much noise. I can close the window. Yeah. So the synthesized answer uses the top X results to combine a summarized answer to the research question. Then there is a reference manager built in Ask as well. That means you can add papers to your library, you can manage library collections, and that can be done, for example, by adding a bib tag or by looking up papers by title, DOI, or just manually entering this data. Because of the bib tag support, it's possible to also import existing bibliographies. For example, you manage your bibliography in Zotero or Mendeley. It's possible to export this and import it in Ask, meaning that also you can ask questions about your own bibliography. So in case you want to extract information from this set of articles. Then another important aspect is filtering. So as you probably also know, if you use most scholarly search systems, the ability to filter is quite limited. You have some standard filters that we also have, for example, based on a year or publication year, based on the language, but it's not really possible to filter based on concepts and so on. Also, Ask is supporting that. So apart from the default filters, we have the custom filters, where you can filter on specific fields in the database. But also it's possible to filter based on specific topics. So here we can select a topic, and from the autocomplete, we have the ability to then find the topic, and then papers addressing this topic will be listed in the search results page. And these topics for now are coming from DBpedia. This explore topics per paper. So this view you currently won't find in the UI, but will be released soon. Then it's fully BibTeX powered the system. So we really try to focus on interoperability and data reuse. So every item can be exported as BibTeX, imported as BibTeX, but also exported in other formats. So apart from the default citation styles, we have some bibliography styles as well. And last week, we also released the LaTeX export, where you can export the data in a tabular form and use it in your own research articles. Then it's possible to save searches. So you can filter the data, you can save those filters. It's possible to remove articles from the search results. And this way, it means you can use ORKG Ask also as a tool to do literature reviews and even structured literature reviews. Since you can store your progress, you can curate your list of results, and finally export this and use it for your research. Exporting also works to the ORKG. So I already said at the beginning, we like to focus on generating really structured data from this as well. So the first step is you can export your data as something called an ORKG CSV. It's basically a CSV file with some specific tags that the ORKG understands. And then you can create an ORKG comparison. So in case you're not familiar with this concept, so this is also a tabular overview of related articles, mostly showing how articles differ from each other or how they are similar. Then, apart from answering to questions, it's also possible to extract custom data. So by default, we extract, apart from the answer that you see here on top, we extract insights, a short summary, conclusions, and so on. But also it's possible to add your own columns there. So in case you want to extract specific data from an article, which makes sense in case it's domain specific, or you want to have the number of participants or something like that, it's possible to add that in a column as well. So I talked about making this a service that is maintainable as well, right? So we focus on usability and maintainability. So for technologies, we try to use the latest web technologies here. So TypeScript, React, Next.js, and also for styling, we focus on that aspect as well. So finally, we also focus a lot on accessibility. So usability includes, of course, accessibility as well. And we do this by, for example, having a fully responsive website. You can use it on your phone, but you can also use it on a desktop, your tablets, and so on. And we have a dark mode. So even a dark mode is actually quite helpful for people with certain disabilities. So it's a nice to have for most people, but a need for other people with disabilities. And in the UI, we really focused on following all the web standards and so on, making sure buttons are accessible, everything has appropriate labels. And I think this is something important to mention because often research prototypes or research tools, they try to have the bare minimum of the prototype. And then the step of accessibility is sometimes skipped. But of course, it's important to always keep that in mind to make sure that everybody is able to use your tools. And the responsiveness, as I said, makes it possible to use your application on different screens, but also makes it possible for people with visibility disabilities to have a very high zoom level and still being able to use your application. That's it for the front end. I think then we move on to the back end.
Great. Thanks a lot. So yeah, I mean, now you've heard some details about the system. You saw the features. I would like to talk a bit what's happening in the background, what's under the hood and how those features are working. It's basically based on some of the stuff that you've already heard in other tutorials today. So I won't really go into much details, but it would be nice for you to have basically an overview of how the system works. So these are also like the set of features or the things that I would like to talk about today. So one by one, I would start with the embeddings. So the term is not really odd. We've heard it today. We saw how this works. There was a Google collab for this. But how is this used in production? So for ORKG Ask, so the first idea when Allard was showing the architecture and there was this vector store. So the vector store contains these documents that we want to search for. So in this case for Ask, we have a bit over 76 million documents. And in order to be able to do some search on top of these documents, we first need to make them more semantically accessible in a sense that we create these embeddings. And again, the embedding is just a vector here. In our particular case, it's a vector of 768 dimensions. And the way we create the vector, so it's the vector for the document as I have it here. So we have the title of the paper or the research artifact plus the abstract, and if it's available, the full text. So this goes into the model, and then in the end, we get a set of vectors out of this. These vectors are all thrown in together into the vector store, and then we can perform other operations on top of that. So now that we have the vectors, we can perform semantic search. right? So in order to do the RAG approach, so RAG is Retrieval Augmented Generation, and the R here, that's what the semantic search is about. As Allard showed, you have a natural query language, which is your research question. You feed it into the system, and then you expect certain set of articles to come out. So this happens via the semantic search. Technically, this is working via the HNSW algorithm, which is an implementation of the approximate nearest neighbor search algorithm. What makes this algorithm interesting and why we chose it? Well, because mostly it relies on filterable payloads. So as Allard showed, again, in the front end, there was these screenshots of the filters. And the idea is that we need to filter the data first and then see what is more suitable for your search query. That's basically what you see happening here. So based on your filters, the amount of data is getting less, and then whatever left, that's what's being compared, that's what's being ranked to your search query and then fed back to the user. Okay, so now that's the R part of RAG, right? So that's the retrieval. We retrieve the set of documents. Now we need to do the generation, which is using the language model. So the way this works in Ask is that we create chains for this. So every time a user sends a question to the system, we retrieve a set of documents, and then in order to generate data or extract information out of those documents, we create those chains. So the chains are prompts, models, and parsers. So the prompt, again, everybody who has worked with an LLM knows what a prompt is, right? So we have a user prompt. In certain cases, we have a system prompt that guides the model into certain criteria. We might have data that's injected into the system prompt, right? So you might want to say, okay, only answer me from this document or summarize this document. So this then goes to the language model itself. For each language model or for each use case, we might have separate parameters to use. We might have a template, how to call the model, right? So some have internally different templates where you say, this is the instruction, this is the user prompt. And because at the end, this is used by code, this needs to be parsed and returned to the user and shown in the front end, we need to be able to parse this information. So that's why we have the parser. So the parser at the end gets the information of the model, and depending on the prompt, so we know for a fact, for instance, if we're extracting data, then we tell the model to stick to a certain format, to a certain specification. And then we are able to parse that. So the parser contains some sanitization logic, some formatting. We maybe even need to convert certain data or convert certain output the model creates for safety purposes or for anything else, right? So these chains are created on the fly for every time we invoke the language model for the RAG operation. So for transparency, Ask uses Mistral v0.2, the 7B model out of the box with the context length of 32K, right? So we have 6 instances of this particular model. So for load balancing, then depending, or we have like a proxy that the load balances the requests coming from the users and then spreads them across those instances to make the experience better. As said previously, the idea is this is a production service, so we need to make it easy to use and the experience smooth as well. Also, our prompts and the way we invoke the model can handle multilingual information extraction. So if the question is coming from a different language, we can also instruct the model to ask, let's say, if you want to ask something in German, then you could also receive the answers in German, although the data that you're looking at is English, for instance, or Chinese or whatever. Okay, so we have LLMs. Now we want to talk about reproducibility. As many of you already know, LLMs are non-deterministic. So every time you invoke the LLM, you end up with a different set of results. And this is nice maybe for your experimentation or when you want to do something, but it's not really ideal when you're using it for science. If you want to extract data from the text, you don't really want each time to get a different result. So ideally, you would want a single result and ideally also reproducible results. So then if you try the same thing on your end, it should give you the same answers. And for this, we seed every generation, right? So seeding, for those who don't know it, is just like a number that you use for the random generator, the random number generator, which makes sure that every time you invoke it on different machine, you will end up with the same sequence of numbers. So this makes sure that the generations will always be the same given the same seed. Why is this important? Because now, given the LLM that I just shown you, that I told you, which is Mistral v0.2, if you run it even on your machine, given the same parameters that I'm using on the system, plus the same seed, you will always end up with the same result, right? And that's the idea of reproducibility here. So then anybody anywhere can reproduce the same extractions just by using same model and same seed, no matter where. Okay, just like a disclaimer. So this is for the backends already implemented, but now the front end is already working on implementing this. So you will not be able to see it in the front end yet, but the API is already there. Okay. Again, let's talk about using this. So this is a production service, so we need to cache things, right? So as you know, using LLMs is not really always fast. So sometimes you need to wait for the results. And for this, you need to, we cache the results. So what you see up here is something a lot of us know, right? So when you go like to ChatGPT or any other interface, you ask something and then you start seeing the words coming, right? So this is called streaming because it's token per token. Whenever a token is produced, you receive this. But as I mentioned, we are extracting information. And sometimes you're instructing the model to create like a JSON or an XML. So you can't really just show the user the values as they come. You need to wait until you get the whole part of the extraction that you need, then parse it, and then basically deliver it to the user. So that's why we cache the responses. So on the first go, it might take a while, but with time, with more questions asked, more documents being retrieved, the faster the results would be. And for this, we have a smart caching mechanism where we try to cache the smallest component. So for instance, as said, let's say here we extract the methods, the limitation, and the data set. But the next time you want to ask for all four plus the metric. So we retrieve all the three that remains in the cache, and we only ask the model for the last one. And when so the metric here in this case, and when metric is extracted, we add it to the cache. So the next user that asks for all four, they get it instantaneously. Okay. There's also the part which is the integration with the knowledge graphs, right? So we talked about the language models. And how can we use this whole thing also in conjunction with the knowledge graph? So you've also seen today a bit about entity recognition. So the idea here is that we want to run entity linking pipelines, right? So some other knowledge graphs like today we talked about Freebase or Yago or Wikidata or DBpedia, they already have entities out there. And the idea, the community have already created so many entity linking tools. So here we try to leverage those tools, in this particular case, the DBpedia Spotlight, where we run them on the documents that we have in our system, right? So we run them on the abstracts, for instance, and we extract those entities. We add them to our system. We add them to the knowledge graph, which helps us basically in more fine-grained filtering. So you can filter on whichever documents talk about a particular entity. And it would also help us in finding relationships between documents. So the documents might be a bit, maybe not really even in the same field, but they could technically still use the same concept or they talk about the same entity. So then there is a certain type of relationship in between those two, right? So the idea is with this, this will keep running. So this is an in-progress task that will keep running. The more data we have, the more entities we have, and then we can also run different entity linkers for different knowledge graphs, and we increase basically or augment our data with linked data that exists out there. As Allard have shown you in the front end. So for those who are interested in this, this is the tech stack that we're using for deploying this. Just a set of inferencing engines for the LLMs, for how basically the API is created for the embeddings, the vector store here for this case, right? So this is just to give you an overview of the tech stack that we are using. It's open source, all of it, so we can just use it however we want in all of our projects. Okay, and it's available online. You can go and try it yourself. And with this would be my part of the backend. I would hand back then to Allard.
Yes, so basically, we have a few more minutes for a quick explanation or a quick demo, and then you can try it yourself, I think, right?
Yeah.
So this is sort of the plan. So we think it would be nice if you get your laptop, you create a bib file and add some of your own publications in there. So preferably publications that are somehow related, because then if you ask a question about these publications, you can see maybe how the answers differ or what information is being extracted. So here are the steps. I will quickly show how this goes, and then I will open this slide again. So we have the ask front end. And the idea is that you go after creating an account to my library, and there you can then see your collections, and you can just create a new collection and import an item from there. And after you create an item, then it's possible to select those items from here. With the selected ones, you can start a new search. And then from here, you can ask a question about those items. So the key point is here that your items that are being uploaded should have an abstract, because otherwise there is no context to extract the information from. You can either add the abstract in your bib tag, or you can, after uploading a bib tag file, change the abstracts and add it from here. And in case there is no abstract yet, let me see if I have one. Well, I just remove it now. So in case you upload an item without an abstract, you can add this from here, click on add fields, and then add the abstract. So after doing that, I can just show that here. So I start a new search. How are these articles related, for example? We can start a search, and then you see the search page that we saw before is opened up, and then the questions are being answered. So you can see this takes some time because it's a private collection, so the data is not already in there. But for the other articles, we can see the data might load a bit quicker. And here we can then see the columns and the answer to the question we just asked. One of the bonus things is you can edit the columns here and maybe ask a specific question that relates to your articles. So you can add something in here that's not just a word, but also a sentence, and then see how the results change. Let's see if there's something else that would be good to show. No, I think that's mostly it. So afterwards you can play around a bit with the UI, maybe export some data or hide other elements that are not relevant. And I think mostly like changing the questions a bit and seeing how that influences the extraction might be interesting to see. So I will open up the instructions again. And just try it out yourself, play around with it, and maybe raise your hand if you have a question to us and we can come to you.